Welcome back, folks. We're going to finish up our lesson on the surface area of prisms and cylinders, and we're going to wrap this up with cylinders. And this one's going to be a little bit longer than the other two. I know the other two were kind of lengthy, but if you haven't watched the other two videos for this lesson, please do that, because we're going to apply all the same stuff we just learned, but this time with cylinders. So what the heck is a cylinder, you may wonder? It's a three-dimensional shape with the base of a circle. So there we have it. Now we have right cylinders where the height is along the side, or oblique cylinders, very similar to our right prisms and oblique prisms that we discussed in the last two videos. And believe it or not, I'm going to tell you something. I'm going to show you the formulas for these prisms, and I'm going to try and convince you that they are the same. So we have the formula for lateral area and surface area of a cylinder. I'm going to convince you is the same as the formulas for the prism. See, the deal is lateral area of a cylinder is still the area around the side. Okay, lateral still means side. Now look at this formula: 2 pi r times h, or pi times d times h. The heck is that? Trust me, it means this: the lateral area of a cylinder is the perimeter of the base times the height. Remember, what's the same thing as our prisms. I'll prove it to you in a second. Let's take a look at the surface area formula of a cylinder. You may think that these are two different formulas. I'm going to convince you that they're not. Make room in your head. So surface area is the lateral area plus 2 times the area of the base, or surface area is 2 pi rh plus 2 pi r squared. And I'm telling you again, it's the same thing as before. It's the lateral area plus 2 times the area of the base. Okay, so how am I going to convince you? We're going to do a quick step back into some really early on circle work. Okay, the first is the circumference of a circle. If you remember, you can find circumference of a circle two ways: by considering the radius, right? So just the radius. Remember the difference. Radius is only from the center out to an edge. The radius of the circle, 2 pi r, is the circumference. Or if you consider the diameter all the way across the circle through the center, the circumference is pi times diameter. Now, what's the deal? I never said the word circumference here, did I? I said the word perimeter. Because one of the things you must understand, that the circumference of a circle it's the same thing as perimeter. It's the same thing, the way around. Okay, so we have to not divorce those two terms. Okay, so when we're thinking of perimeter and circumference, make sure you recall that they are the same thing. Okay, so how do we find the circumference of the circle? How do we find the perimeter of the circle when we're considering the radius, 2 pi r, or the diameter, pi times the diameter? Because guess what 2r is, folks? Guess what 2 times the radius is? It's the diameter. So the formulas are the same. It doesn't matter how you remember it. Personally, in my head, I grew up with 2 pi r. That's all I remember. I don't remember pi times diameter. I can easily get there because I know how diameter and radiuses work. But anyway, take that as you will. We have to also remember that the area of a circle is found by multiplying pi times the radius squared. So I'm telling you, it's the same as what we just did with with prisms, but this time with cylinders. So the lateral area is still the perimeter of the base times the height. Surface area is still the lateral area plus 2 times the area of the base. Now we're just using pi for circles. Speaking of pi, let's talk about pi for a second. Yummy. Pi is yummy. Pi is pi. You understand? You probably don't. This is what I'm cautioning you. Do not use 3.14. That's not pi. Do not use 3.14 unless we call for rounding or measurement or rulers or things like that. Pi is pi. We call pi pi. That's it. Pi is pi. Never use 3.14 unless you are asked to do so and it calls for rounding. So we're looking for measurements and things like that. In that case, we only use 3.14 at the very, very end. Do not round until the very end. 3.14 is an estimation of pi. It is not pi. It's a bad estimation, but it's the closest we can come to. Okay, so pi is pi, not 3.14. Remember that. Knowing all this, let's get to work, folks. Come on, Josh, hurry up. I mean, Mr. Katz, whatever. So let's get to work. We have the diagram of a cylinder. How can we visualize the circle with the rectangle is the net of the way, by the way, of a cylinder. A cylinder has a net that is a rectangle in two circles. Isn't that cool? So we can consider that as well. We can find area that way as well. It just makes the the length of the rectangle a little tricky because the length of the rectangle is the circumference of the circle. What? Anyway, here's our problem. With the radius of the base of a cylinder and a height, we're going to find the surface area. And we're going to keep it in terms of pi. What does this mean? This means no rounding. No rounding. What this means in terms of pi is what I said here. Pi is pi. Call it pi. You'll see how that works in a second. So we're going to find the surface area. How do we find surface area of a cylinder? The surface area is still the lateral area plus 2 times the area of the base, which still means we need to find the lateral area first. And how do we find the lateral area? The perimeter of the base times the height. Okay? It's still the perimeter of the base times the height. Now, how do we find perimeter of a circle? Remember, perimeter is simply the circumference. So perimeter is 2 pi times the radius, or pi times the diameter. Okay, so that's the only difference here. In this case, we give us the radius. The radius is 4 inches. So we know the perimeter. The perimeter is 2 times pi times the radius, or 4 inches. So what do we do with this? If we're saying pi is pi, treat it just like an x. Okay, if that was an x, what would we call it? We would say that the perimeter in this case is 8x, or 8 pi. So that is our perimeter, 8 pi. So we're looking for lateral area, perimeter times the height. The perimeter is 8 pi. What then is the height? Well, we look at the problem. It gives us the height is 6 inches. Okay, so we have our lateral area will equal our perimeter, what we found as 8 pi, times the height. Perimeter of the base times the height. The height is 6 inches. So what is the lateral area? The lateral area is 48 pi. Okay, so we want to keep it in terms of pi. That's what it means. So when it says keep it in terms of pi, we're keeping pi as pi. We're going to treat it like an x. Okay, so that's what that means. Now that we have found our lateral area, we're ready for surface area. The only thing that's missing in surface area is the area of the base. And how do we find the area of the base? It's still a circle. And how do we find the area of a circle? Pi times the radius squared. Okay, so we have to remember the area of a circle. Pi times the radius squared. Now our radius is still 4. Okay, so we're looking at pi times, in this case, 4 squared. Now, 4 squared is 16, so our area of the base is 16 pi. Okay, so the area of the base is 16 pi, which means that 2 times the area of the base is 2 times 16 pi. And again, we're treating that pi like an x. So keep in terms of pi. So that means 2 times our base is just like 2 times 16x, 32 pi. So what is our surface area? It's adding these two values. The lateral area plus 2 times the area of the base, which gives us 80. So surface area is lateral area plus 2 times the area of the base, which is, lateral area was 48 pi, and 2 times the area of the base was 32 pi. So our surface area is 80 pi square inches. If we were rounding, this is where we would multiply 80 times 3.14. But we're not rounding, we're keeping it in terms of pi. And that's how that works. Let's do a couple more examples. We'll get good at this. Okay, so now we're looking for more surface area of a cylinder. In this case, a cylinder has a height of 9 centimeters and a radius of 10 centimeters. We have all we need to know. Because the question is asking for surface area. And again, surface area is the lateral area plus 2 times the area of the base. We still need lateral area. Lateral area is still found perimeter of the base times the height. But since the base is a circle, perimeter is going to be circumference. So perimeter is going to be 2 times pi times the radius. The radius is 10 centimeters, so it gives us all we need. So the perimeter is going to be found by multiplying 2 times pi times 10. So we have our perimeter of the base, 20 pi. All we need now is the height. Again, it gives it to us. The height is 9 centimeters. How convenient. So the lateral area is going to be 20 pi times the height of 9, and that is 180 pi square centimeters. That is our lateral area. Now what we need is the area of the base. Okay, so the area of the base is still a circle. So it's still pi r squared. Okay, so it's still a circle, still pi r squared. We can use the radius. So pi times the radius is still 10 centimeters, and the formula still says radius squared. 10 squared is 100. So the area of one of the bases is 100 pi. But we need to know 2 times the area of the base. So 2 times the area of the base is 2 times 100 pi, also known as 200 pi square centimeters. So we have our surface area then. It's the lateral area plus 2 times the area of the base. So surface area, again, is our lateral area plus 2 times the area of the base. Say that, guys. Say it. If you say it, you will know it. I guarantee it. Oh, my goodness. So the lateral area is 180 pi. 2 times the area of the base is 200 pi. So that's 380 pi. Squared centimeters. Don't forget your units of measure. Okay, and that's in terms of pi. Okay, so when we say in terms of pi, that's what we mean. Treat pi like an x. Now, what if it wasn't so simple, right? What if we were actually measuring a thing? So let's look at lateral area of a cylinder. This is kind of interesting. So let's take a painting example. We're going to use a paint roller brush, right? So we're going to use a stencil roller to paint patterns on the floor. What area does the roller cover in one full turn? Now, one full turn makes it just the lateral area. It's like, what's the side? So we have to know what we're talking about. In one full turn is just lateral area. Now, how do we know that? Well, we're not taking in the area of the circles, right? We're not taking into account the area of the bases. It's just the area of the side, right? One turn is lateral area. It's understanding what lateral area is. So, in this case, we have it. We have all we need to know. The lateral area is the perimeter of the base times the height. And what's the perimeter of the base? 2 times pi times the radius. Now, remember what I told you before in the formulas for the area of a circle. Okay, so when we looked at the formulas for the area of the circle, remember that 2 times the radius is the same thing as the diameter. And the diameter is all the way across. Okay, so the diameter is all the way across. We've got to remember that. So that's gonna help us out here. Because 2 times the radius is all the way across, 2.5 inches. So the perimeter of this particular base is going to be 2.5 times the height of 6 inches. So, wait, that's times pi. Come on, cats, pay attention. So 2.5, which is the base, times pi. Okay, so diameter means. So 2.5 is diameter, pi is pi, so that's how we find the perimeter of the base. So the perimeter of the base is pretty simple, 2.5 pi. Okay, that's easy enough. All we need now is the height, and we have the height, right? The height is 6 inches. See how this works? The height is 6 inches. So the lateral area is very simply 2.5 pi times the height, times 6. We have all we need to know. The problem is we're looking for area, and so we're looking for actual numbers, right? We're measuring. So in the case here, we're going to measure, so 2.5 pi times 6, which is 15 pi, by the way, but you can put that in your calculator, 15 times 3.14, and you'll end up with your 47.1 square inches, or however it is that we're asking for. So we said keep it in terms of pi, 15 pi. If we're measuring, rounding to the nearest what have you, calculator work. Okay? So one last question, you'll see that we don't need anything. Without a picture, cylindrical stencil roller has a height, whatever, what does the roller cover in one turn? And again, you have to see that in one turn means we're talking about lateral area. So let's do this one really quickly again. Lateral area is still perimeter of the base times the height. Perimeter of the base in a circle, 2 pi r, or pi d, by the way. Pi times the diameter. It tells you the diameter is 2.5 inches, so that's helpful. So our perimeter remains the same. Perimeter of the base is still the same, 2.5 times pi. All we need now is the height, and the height is given to you, 1.5 inches. So lateral area, piece o cake. It's already given to us. So the lateral area, 2.5 pi times 1.5. And the rest is calculator work. Now this one says round your answer to the nearest tenth. So we do need calculator work in this example. And we punch everything in the calculator and we get 11.8 square inches. And that is how we work with surface area and lateral area. Now we're going to end the whole lesson with a quick quiz. And when I say quick, I'm talking super quick. Take a look at this first question. What is the surface area of the cube? Now, if you want to use the surface area formula, being the lateral area times 2 sine the area of the base, go ahead and do this. Here's how I'm going to show you a shortcut. It's a cube. You know what a cube means? All the same length. Everything is the same. 8 millimeters here, 8 millimeters everywhere. And in a cube, there are 6 faces. And what's the area of each face? The area of each face is 8 millimeters times 8 millimeters, or 64 square millimeters, but there are 6 of them. So 6 times 64 will give us our area, and that should come out to be 384 square millimeters. And that is your surface area all the way around. So if you understand some stuff, life is going to be a lot easier. Now, if we look at the next question, we have to know what we're talking about. The pillars in front of Mr. Jefferson's home are shaped like cylinders. Cylinders. The pillars have a height of a whatever and a radius of whatever. How many square feet of paint are needed to cover each cylinder? Think, paint. What are we going to use? How do we paint the pillars of a house? We're talking about paint. We are talking lateral area. That is so important. Lateral area, I'm yelling. And we know how lateral area is found. Perimeter of the base times the height. How do we find the perimeter of the base? It is a circle, 2 pi r. So 2 times pi times 8, or 16 pi. What is the height? The height is given to us at 24, so we're going to multiply 16 pi times 24. The rest is calculator work, and we're going to boop, 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 and we find out it's going to be 1205 point whatever. Excuse me. So that's what we do. That's how we figure that out. So that was a quick quiz, putting everything together. Hopefully you learned some stuff about surface area. We'll come back for cones and pyramids later. Take care, y'all.